laser position.
So this is a laser positioning system. It works with a light. Where's the lighthouse?
It's right there.
Oh, so this is the lighthouse. They should see the flashes on the video, but you can't see it at the moment. But I thought does it not scan?
Yes, it's infrared laser, so you can't actually see the laser beam.
So it scans the room like a TV screen, like a raster.
So it emits a synchronization pulse, which is omnidirectional.
Yeah.
In every direction.
Oh, okay.
That lets the sensor know, okay, it's about to start a new cycle.
Yeah.
And then it emits a horizontal sweep. So it's a plane of light that sweeps across until it hits a laser and then captures the information.
So let's be clear. So this is already available from a marketable product,
right.
and what you're doing is you've redesigned the receiver end here.
Yes.
So this is the bit that you've done.
Yes.
So you've got FPGAs, isn't it? Or something?
No FPGAs.
Oh, and micros this time.
Yes. So it's all microcontrollers. Here's a sensor taken off one of the surfaces. So it's a 10 megahertz microcontroller that interfaces an I2C to Raspberry Pi.
Okay.
And so the 12 sensors continually talk to the Pi and transmit the angle information to the Raspberry Pi, which then transmits that serially through wireless communication to the PC.
So just for the viewers, so to speak, this whole pyramid structure goes on whatever it is you're trying to measure. So that goes on your robot or whatever, is it? This pyramid.
You take
so
it, stick it on our robot.
And then you'll be able to know exactly where it is in the room, to what sort of precision. But roughly less than a centimeter sort of thing.
In theory, millimeter accuracy, and the angle information we're getting is the accuracy here, right? So you can see, the sensor information relative to the lighthouse. So negative 11 degrees.
Oh, so basically you need the coordinates of the room to make an XY coordinate. So, but you do that for any particular environment. So you need to map out the environment first.
Exactly. But you would automatically know exactly where it is relative to the base station at all times. So if you know where the base station is, you know where this is.
Then you'd make a graphical map or something, and you have some sort of cursor, and it moves along as it's moving.
You could do that as long as you knew where the base station was relative to everything else.
So this thing solves 4 simultaneous equations or something, isn't it? Or something?
Yeah. So once you have 4 sensors illuminated, compare pairs of sensors, right?
Yeah.
So you actually measure the physical distance between each sensor, and you put that in an array, right? And for example, if you have 2 of them illuminated, you know the angle between them, you know how far apart they are in real space, so you know the maximum distance they have to be away from the lighthouse.
Yes.
If you compare 4 pairs of them to the lighthouse, you actually can figure out how far away it is.
So you can tell if it was up in the air as well. So it's not just on a 2-dimensional plane. It's anywhere in space.
It's 3-dimensional. Yes.
That's quite interesting.
And I can show you the.
So this isn't on this is on a Linux machine, obviously.
So this is on Linux, and then I'll show you the GUI on Windows that gets transmitted.
Oh, you have got something. Okay. Oh, I see. You got a wow. Very. It's not doing that funny ambiguous flip, is it? That it used to do on the other one. No, it doesn't. It doesn't. Oh, you got to hold it really steady because it's so sensitive.
Yeah. It's a little sensitive.
There might be a simple way to get around that by putting some dynamics on the sensor.
You can see the other face come into view.
So just to let people know he's moving this
I have
by hand.
2 faces facing the.
As he's moving that, he's moving the image. So that's the orientation, and it knows where it is. Do you get sort of reflections and things, or you always?
Yeah, you occasionally get reflections, but it should be pretty robust in that sense. It's the GUI is very, very sensitive at this stage right now.
Yeah.
But so that's that.
I guess it doesn't need to respond quite as fast as that, does it? I mean, for most applications, unless you got a missile or something. I mean, it doesn't. It's pretty sharp. You could put some kind of dynamic damping in it, perhaps, so that it gives though it's slightly lagged, it might look better on the screen. You know, that might be possible. Yeah.
For display purposes, definitely.
Yeah.
For sure.
Anyway, okay, that's it. Okay, thank you very much.